Hi everyone, this is V.T. Gopinathan, Assistant Professor, the Department of Aeronautical Engineering of Hindustan College of Engineering Technology, Coimbatore. In this presentation, I'm going to talk about the stability introduction for aircraft stability and control. This slide shows the recap of the rotational displacements. We know that there are three rotational displacements are applicable for an aircraft. The one is pitching, the second one is rolling, the third one is yawing. The pitching moment is about the lateral axis, the axis which is passing through the wingtip to wingtip. The second one is the rolling moment is about the longitudinal axis, the axis which is passing through the nose to tail. The third one is the directional axis, the moment is yawing moment, the directional axis is passing through the center of gravity. So these are all the three displacements. The next one is we are going to discuss about the stability. The stability means it is ability to stable. As far as the airplane concerned, the stability is the inherent quality when the equilibrium state is disturbed. Without any control actions by the pilot, the airplane should coming back to the original position or equilibrium position. That is called stability. So the stability is the initial tendency of an airplane in the flight to remain in straight, level flight, upright flight, and to return to this attitude if it is displaced because of the disturbance without corrections actions by the pilot. If we take the stability types, the stability can be typed as two. The one is the static stability, the next one is the dynamic stability. Again, the static stability can be classified as positive static stability, negative static stability, and neutral static stability. Similarly, the dynamic stability also can be classified as the positive dynamic stability, the negative dynamic stability, and the neutral dynamic stability. The static stability is the initial tendency, whereas the dynamic stability is the overall tendency. So the stability concept can be explained through the simple pendulum. Here the first diagram shows the simple pendulum. Here the bob weight is W. The bob weight W is balanced by the tension force. When the bob weight W or the bob is displaced, then it makes an angle theta from the initial position. When it makes an angle theta, then bob weight W can be resolved into two components. The one is W cos theta, the another one is W sin theta. Here the W cos theta is balanced by the T dash. Similarly, the W sin theta is unbalanced. So because of this W sin theta, the bob is try to return to the original position. That is the initial position. So that is the stability. If I are taking the second one, here the bob weight W is balanced by the compression C. Again, if it is displaced, again it makes an angle theta like the previous one. Here the W in the bob weight, now it can be resolved in the two components. The one is W cos theta, again the W sin theta. Similarly, the W cos theta component can be balanced by C dash, and the W sin theta is unbalanced but it is acting in the opposite direction. So here there is no possibility to the bob to return to the original position, it is moving away. So likewise, when the object is displaced, if there is any possibility to create the restoring forces to bring the object to the original position, then automatically it will coming back to the original position. Otherwise, it will move in the disturbance direction. So from this concept, again the stability can be classified into two. Already we have discussed the one is the static stability. So the static stability is all about the initial tendency of the body to return to its original position. Whether the object has the tendency to coming back to the original position after the disturbance. There are three diagrams are available in this slide. The first one is the ball is on the surface. When it is displaced, then it is slightly oscillating. Then after the disturbance, it is coming back to the original position. If you take the second one, if there is any small disturbance, then the bob or the ball will move in the disturbance direction. There is no possibility to coming back to the original position. If you take the third one, if the disturbance is given on the body or the ball, then it will take a new position. So according to the equilibrium position attained by the object after giving the disturbance, the first one is considered as a positive stability. Why it is positive stability? It has a tendency to coming back to the original position after the disturbance. If you take the second one, once if the disturbance is applied or the disturbance is created on the ball, then there is no possibility to the object to coming back to the original position. So it is considered as a negative static stability. The third one is considered as a neutral static stability. because there is the absence of restoring forces or moments to bring the object to the original position. Similarly, the second one is, or the classification of the stability is the dynamic stability. The dynamic stability is the overall tendency of the mechanical system. So what is the final position of the system after the disturbance? Usually, the dynamic stability will give the answer for the question whether the object is coming back to the original position or the equilibrium position after the disturbance with respect to time. That is the main thing in the dynamic stability. So it is concerned with the time history of motion after the disturbance. So whereas the dynamic stability is the overall tendency and the static stability is the initial tendency. Again, the dynamic stability can be classified into three. The one is the positive dynamic stability, the second one is the dynamic stability, negative dynamic stability, the third one is the neutral dynamic stability. So here the first one is the damped oscillation can be considered here. Here the oscillation is considered. So with respect to time, when the time is increasing, the oscillation is slowly getting down, it is damped, then at last finally the object is coming back to the original position. So there is possibility to bring the object to the original position because of the damping oscillation mode. So this damped oscillation mode is the positive dynamic stability. The second one is the divergence oscillation. With respect to increasing time, the oscillation or the amplitude is increasing, which means the disturbance is increasing. So the object will never coming back to the original position. So the divergent oscillation category is considered as a negative dynamic stability. The third one is it is undamped oscillation with respect to increasing time. There is no overshoot or there is no increment of the disturbance. At constant amplitude, that is oscillation is continuous with the increasing time. So this is called neutral dynamic stability mode. So if we are taking the different types of motion following a disturbance, all the items are available in this slide. The first one is the damped oscillation. The second one is the divergent oscillation. The third one is the undamped oscillation. The fourth one is the subsidence motion. It is not like an oscillation. The fifth one is the divergent oscillation. The sixth one is the neutral stability. So all the types of motion is applicable for an aircraft also. So when we are talking about the static stability and dynamic stability, then we can check whether all these types of motion has the static stability as well as the dynamic stability, which means all the types of motion has the initial tendency as well as the overall tendency. So we are going to see the one by one whether all these six different type of motions has the initial tendency as well as the overall tendency. So before moving to the next slide, just to remember all the motions in your mind, then it will be very much useful to solve that table. So this is the case, static stability and dynamic stability. The case category, already we have listed out the different motions. The one is the damped oscillation, divergent oscillation, undamped oscillation, subsidence motion, divergence motion, and the neutral stability. So if you want to check whether each case has static stability and dynamic stability, we should remember one important thing, that is nothing but the static stability is the initial tendency, whether the object is trying to coming back to the original position or the equilibrium position. The dynamic stability is the overall tendency, whether the object has the tendency to coming back to the original position after some time, or what is the final position of the mechanical system. So the first one is we are going to take the damped oscillation. In the damped oscillation, always the object is trying to coming back to the original position, which means it has the initial tendency. Similarly, after some time, when the time is increasing, because of the damping, the object is coming back to the original position. So the dynamic stability is yes. So the Y stands for yes. For damped oscillation, static stability yes, and dynamic stability is yes. The second one is the divergent oscillation. When we are taking the divergent oscillation, the oscillation is increasing with increasing time. But the object has the initial tendency to coming back to the original position for each oscillation. But if you are taking the final position of the mechanical system, the object is never coming back to the original system. So the dynamic stability is no. Similarly, if you are taking the undamped oscillation, the case is similar like the divergent oscillation. Here also it has the initial tendency to reach the original position or equilibrium position. But with respect to increasing time, if you are taking the final position of the mechanical system, it is keep on oscillating. So the dynamic stability is no. Similarly, if you are taking the subsidence motion, there is no oscillation here. But with respect to increasing time, the disturbance is slowly damped out. So the object is coming back to the original position after the some time. So it has an initial tendency as well as the overall tendency. The next one is the divergence. In the divergence, there is no possibility for the static stability because with increasing time, it never coming back to the original position. slowly moving in the opposite direction or in the direction of disturbance. So it has no initial tendency, there is no overall tendency. So no static stability and no dynamic stability. Similarly, if you are taking the neutral stability, there is no increment or there is no decrement in the disturbance. With respect to increasing time, the object is moving in a constant amplitude. So the neutral stability, static stability is no, and dynamic stability is no. So from this different cases and the static stability and dynamic stability discussion, the conclusion is, if the system to be dynamically stable, the first condition is the system must be statically stable. The second one is, even if the system is statically stable, it is not compulsory to be a system to be dynamically stable. That is the second one. The third one is, if system doesn't have any initial tendency or static stability, the particular system cannot have the dynamic stability. Thank you so much for watching this video.